So this video is going to help us go over the calculations for our experiment 9 determination of an equilibrium constant. So what I'm showing you is the data sheet first page. And the first thing I'll mention is all of this first page should have been completed from the lab when you attended lab. Or from the remote version of the lab. So the only thing we really need for calculations is I put a class average sample data of 1.22 molar for our sodium hydroxide concentration. Yours is going to be slightly different based on your section's class average, but we're going to need this for our analysis. On the next page, this is also data that you should have collected in lab, so these are your titrations. The important things we'll need to go over the data analysis. All of these should be completed from your data, but we'll need some of these final total volume of sodium hydroxide added. So I filled in some sample data just so we can show you some calculations. So again, these will be different numbers than what you have, although probably approximately in the same ballpark. So recall the goal of this lab is to determine the equilibrium constant for the reaction of ethyl acetate and water to produce acetic acid and ethanol. And so in order to do this, we're going to eventually have to go through an ice table. So if we scroll down just to show you where we're going, we can see that in our equilibrium, we have really three reactions that we looked at: Flask 2, Flask 3, and Flask 4. And what we did was we varied the amount of ethyl acetate and water in each of these flasks. And what we're going to be doing now is filling in the initial concentrations of ethyl acetate and water. We know at the start of reaction in all of these, the initial concentration of acetic acid and ethanol is always 0. And then what we're going to then do is we're going to calculate what the initial concentrations of these are for each flask. Okay, so we'll have those values. And then we will determine what our acetic acid concentration is in each flask. And if we know the acetic acid concentration, that is going to tell us what the ethanol concentration is, since essentially we're starting with 0. The acetic acid concentration is equal to X, so ethanol is going to be the same thing. And if we know what X is, we can go ahead and subtract X from our initial, and we'll be able to determine this equilibrium concentrations of these, eventually to plug in and get K. Okay, so there's a lot going on there, so let's back up and go to our data analysis. So the first thing we need to do is we need to calculate the initial concentrations of things. And so this is sort of explained to you in text here, so you can read through it. The first thing we're going to look for is we're going to need the initial molarity of ethyl acetate. All right, so before each reaction takes place, what is the initial concentration of ethyl acetate? Notice after we mixed everything into each flask, the total volume of each flask is 10 milliliters. So really what we want to do is figure out how many moles of ethyl acetate are present and then divide by 0.01 liters to get the concentration. So let's back up for a second and go to our tables here. So if we look at flask 2, we can see in solution 2, we pipetted 5 milliliters of ethyl acetate. So that 5 milliliters is where we're going to start. And the idea is we're going to take that for flask 2, and you might need more paper to show all of this. So for flask 2, we want to convert 5 milliliters of our ethyl acetate. I'm going to convert that into moles. And then from moles, get to our molarity in the flask. So to get to go from milliliters to moles, the first thing we're going to do is we're going to go ahead and use our density of ethyl acetate, which is given here, 0.893 grams per cubic centimeter or per milliliter. And from up above again, what we said was we have 5 milliliters. So we're going to start with that 5 milliliters, 5.00 milliliters, and the density is telling us that we have 0.893 grams for every 1 milliliter. So if we go ahead and multiply that out on your calculator, we'd end up with 4.465 grams. And then what we need to do is go to moles. So I'm going to take that 4.465 grams and now divide that by the molar mass, grams per 1 mole of ethyl acetate. So we're going to need to calculate the molar mass of ethyl acetate using the molecular formula shown here. And when I did that, I got 88.104 grams. So we multiply that out, I get 0.0507 moles. And again, what we're looking for is the concentration of ethyl acetate. So that's going to be equal to our moles, 0.0507 moles, over our volume, which is 10 milliliters, converted to liters, 0.01 liters. And so what we see from that is the concentration of ethyl acetate is equal to 5.07 molar. And that is for Flask 2. So what we can go ahead and do is come down to our ice table down below, and we're going to systematically be filling this out. So we see our initial concentration is 5.07 molar. So we have one step done. You will now need to go through and do a similar calculation to find the initial concentration in Flask 3 and Flask 4. And the only difference of those calculations is going to be what was your initial volume of ethyl acetate. And you'll have to go through those. So next, what we need to do is calculate the initial concentration of water in each flask. And water is going to be a little bit more complicated than ethyl acetate, because when we look at the water, we see in Flask 3, for example, we added 3 milliliters of water. In Flask 4, we added 2 milliliters of water. So what we would need to do is convert these 3 milliliters of water into moles of water. Okay. But that's not the only water source. We can see Flask 2 doesn't seem to have any water, but it does have 5 mils of 3 molar HCl. And recall that this is 3 molar HCl, so that is an aqueous solution. Most of this 5 milliliters is water with a little bit of HCl. So what we need to do is figure out, of these 5 mils, how much of it is water. And that's going to tell us the initial concentration of water for solution 2. In solutions 3 and 4, we have water we have to figure out the moles of, but we have the same 5 mils of the 3 molar HCl. Okay, and so the key is however many moles of water we determine are here will also be here and will also be here. But then we can add the 3 mils and the 2 mils as we go on. So what does that look like? Well, when we go through this, we can see the first thing we need to do is to use the titration volume for Flask 1 and the molarity of the sodium hydroxide to calculate the moles of titrant base added. And really what we're doing here in these first two is we're trying to find now how many moles of acid are in 5 milliliters of 3 molar HCl. Okay? And whatever's not acid is going to be water. And so I'm going to go to my titration data. We need this titration volume. So your number is going to be different here. And I'm going to take this 12.5 milliliters. I'll come down here. And I'm going to take that 12.5 milliliters, I'm going to convert it to liters, 0.01250 liters. And I'm going to multiply that by my concentration of sodium hydroxide. Right, so this was the class average. So now I'm going to look for the class average, 1.22 moles per liter. So we get 1.22 moles per liter. And we can see our liters are going to cross off. I can do that in my calculator. 125 times 1.22. And I got 0.1525. And let's label that, because what did we find here? This was moles of sodium hydroxide. So that's how many moles of sodium hydroxide it took to reach the endpoint. Okay. How many moles of acid are in the flask? Well, the key here is, remember, at the endpoint, the moles of base added are equal to the moles of acid. And so now we see 0.1525 moles of our acid. Once we have that moles of acid, we need to go 0.1525, and your number is going to be different, of course, moles. And now we have to go to grams. So convert acid to grams. So we're going to get grams of HCl per 1 mole, and we're going to end up with grams of HCl. I'm going to leave you to do this calculation now, and this will tell us how many grams of HCl we've added. In the next question, what we're asked is, in this same 5 mLs of the catalyst, we're going to say the density of the solution was 1.03 grams per ml. So calculate the total mass of the solution. Okay, so here what we're going to do is, very simply, we're just going to take our volume and our density to get a total mass. So we're going to take our 5.00 mils, that's what we pipetted. We're going to multiply that by our 1.03 grams per 1 mil. We're going to get 5.15 grams of HCl solution. So let's just think about that for a second. This HCl solution contains HCl and it contains water. The total mass is 5.15. Okay, so in number 5, what we're saying is, how much of that is water? The total mass is 5.15. In part 3, you calculated the mass of HCl. So we can use those two. We can subtract those two and determine, and so we can find the grams of water. So you can calculate that, again, by subtracting 5.15 minus the grams of HCl you got here. This will give you the grams of water. Once you have the grams of water, we can go to moles of water, right? So this is just going to be using the molar mass. So again, we're going to have the same grams of H2O. Let's go ahead and go to moles. So divide by our molar mass, 18.01, 1 mole, and we're going to be given moles of H2O. So then finally, once you have moles of H2O, to find the molarity of H2O, it's just going to be the moles of H2O divided by our total volume, which again was 0.01 liters. All right. So again, we're going to see the moles of H2O would go here, divided by 0.01 would give us our initial concentration. And this value is a different color here. This value here that we're going to end up, that is the initial concentration of water for our ice table in solution 2. Okay, now that's for solution 2. For solutions 3 and 4, we have to do a little bit more. And the key is for solutions 3 and 4, so for example, for Flask 3, the concentration of water is going to be equal to, again, the same volume. Everything's in 10 milliliters or 0.01 liters. And now we need the total moles of H2O. And that total moles of H2O is the moles of H2O from the HCl plus moles H2O from pure water. Okay, and so what I mean by that is when we look at that, this moles of 8 from water, these two numbers are the same. So once you have that, we can plug that in. But we also now need to figure out this. And this comes from how many moles of water did we pipette. And so if we go to Flask 3 took this 3 mils of water. So we're going to come down here and say 3.00 milliliters of water. We need to convert that into moles of water. All right, and as you do that, some good things to keep in mind. Recall that with pure water, the density is 1 gram per milliliter. Right, so if you know it's 3 milliliters, it's also 3 grams. So you should be able to convert that to moles, add that to the total moles to get the initial concentration of water. Once you have that, you can plug in your initial concentrations of water for solutions 3 and for solutions 4. On part C, moving on, this part C section here, this is just to put this information on the page. This is actually the same calculations you've already done from part B, 1 and 2. So these two questions are the same exact questions here, so you can just copy your answers down. And this is just a reminder. What we're now going to be doing is figuring out how much acid was in each of the flasks from our titration data. And remember, the total acid in each flask is HCl and acetic acid. All right, so it's got the acid catalyst and acetic acid. You always added the same amount of catalyst. So this answer here is the same amount of moles of HCl that would be in flasks 2, 3, and 4. Okay. Now, what we can now do is we can start going through these calculations. And number 3 here is going to now ask us to calculate the total amount of acid in flask 2. Right? And the way we're going to do this, and we'll have to do this for flask 2, flask 3, and flask 4, we're going to get this from our titration data. So all of this is based on our titration. And so what we're going to do is use the average molarity of sodium hydroxide, which is going to be different for everybody, for each class, and then your data in the titration. So for flask 2, we can come up to our titration data and say, this is the volume of sodium hydroxide it took to reach the end point. So I'm going to come down here at 33, and I'm going to say my data said 0.033 liters multiplied by 1.22 moles per liter. And when I did this, I got 0.0396 total, moles of base, which equals total moles acid at the endpoint. Now, that's the total moles of acid, which has two components. It has the acid catalyst and the acetic acid, right? So we can now take our 0.0396 moles acid and subtract the moles of HCl, and that moles of HCl will be the number you have here, and that's going to equal the moles of acetic acid. You have to do this with each of your solutions. We're then going to take the moles of acetic acid by our total reaction volume. So what we really want is acetic acid concentration equals moles over that same 10 milliliters, 0.01 liters, right? And again, here, this value is going to go right here into your moles. Once you have that number, this goes into your ice table. And then in number 6, we're asked for the concentration of ethanol. And again, the key here is think about the stoichiometric ratio. Right? So because these are in a 1-to-1 ratio, whatever you get for an answer of acetic acid will also be the answer for your ethanol. So that allows us, we should now be able to plug in our acetic acid at equilibrium and our ethanol at equilibrium, right? So those values are what we just got here and here, which now allows us to go through and calculate all of our values. You should be now able to determine your equilibrium concentrations of ethyl acetate and water, which allows you to calculate K. And once you have K, you can go ahead and answer the rest of the questions. So I hope that helps walk you through the data analysis. If you have any questions on that, please let me know.